Assalamu alaikum dear student, this is Walid Risha and today we are here to discuss the topic Amperes law which is given on page number 116. Amperes law or Amperes circuital law discovered by Henri Marie Ampere in 1826 relates the integrated magnetic field in a loop around a current carrying wire to the current passing through the wire. We know that there is a magnetic field around a current carrying wire. If we consider a closed path around the wire in the form of a circle having a wire at the center, then the magnitude of the magnetic flux density B changes with the current I in the wire and the distance R from the wire. According to this Ampere's circuital law, for example, if we have a current carrying wire like this, in which the direction of the current is in upward direction, so according to right hand rule, the direction of the magnetic field should be like this, means anti-clockwise. So according to Ampere's law, we can find the magnitude of the magnetic field produced by the current passing through the wire. According to Ampere's law, the magnetic field produced in this wire is directly proportional to the current magnitude. Again, magnetic field is inversely proportional to the distance from the current carrying wire. If we increase the magnitude of the current in the wire, so we can actually increase the magnitude, the strength of the magnetic field around that wire. Second point is that the magnetic field is inversely proportional to the distance R from the wire itself. So, if we actually, for example, in increasing the distance, we can decrease the strength of magnetic field. So, magnetic field will be stronger along this circle as compared to this one. So, magnetic field is inversely proportional to the distance from the current carrying wire. Combining these two, we can have like current I over R. Or converting this relation into an equation, we can write mu naught divided by 2 pi I over R. So, what is mu naught? Like permittivity of the free space in Coulomb law, we have a new concept very similar to permittivity of the free space. We have a concept permeability for the magnetic field. We can call it permittivity for electric field, but for magnetic field we can call it permeability. So permeability of the free space is given the value 4 pi into 10 raised to power minus 7. 4 pi into 10 raised to power minus 7 Weber per ampere per meter. This is the value of mu naught. This symbol will be pronounced like mu naught, permeability of the free space. And we have 2 pi. Like in Coulomb law, we had 4 pi because that was some sort of spherical concept. But here we are taking an Amperian loop like a circle, which is a two-dimensional concept we have in 2 pi angle for a whole circle. So the concept is 2 pi for Ampere's law. So we can write this equation like mu naught I divided by 2 pi R. This is Ampere's circuit law for a current carrying wire which is producing a magnetic field B around itself. Okay. We can generally write Ampere's law like let us suppose we have a current carrying wire. We take an anti-clockwise magnetic field like this. To derive the same Ampere law, let us divide the whole circular path into small lengths like L1, L2, L3, L4 and so on, Ln. So, as previously we have written like D is equal to mu naught I divided by 2 pi r. We can write it simply like for a closed path, a circular path around the wire, like B dot delta L is equal to mu naught I. What is delta L? Delta L is the small element of this circular path, like L1 R, L2 R, L3 R, L4. Now, combining all these small segments of the whole circular path, we can write it sum of all the dot products of the magnetic field and the small segment of the circular path like mu naught and the total current enclosed by the conducting wire, that is I. So this is another form of the Ampere circuit law. Ampere law simply explains that when a current is passing through a conducting wire, so the magnitude of that magnetic field will be dependent upon the magnitude of the current. Thank you and have a nice day.